All right, good afternoon, everybody. Can everybody hear me fine? Stuff like that? Just leave something in the chat and then we'll start. Okay, thanks, Gene or Shane, one of the two or both. So let's get started with this one, going serverless with Google Cloud Run. Let me just focus the right screen here. Yes, that should be it. Going serverless with Google Cloud Run. Today's today, yes, and we're at JSConf. Excited for this talk, so am I. So my name is Bram. I'm a developer from Belgium. I have a blog, it's bram.us, and I'm also on Twitter. It's @Bramus handle, and my blog is also on Twitter because apparently not everybody likes RSS, so it's also on there if you do want to follow it. I work at vBridge. It's a company that I founded together with a partner of mine, and we thrive at the intersection of cloud platform architecture, cloud native development, and industrial IoT. We use a mix and match of different languages. We use PHP, we use JavaScript, we use Python too. Then we run things on the Google Cloud Platform, we use Terraform, Kubernetes, stuff like that. So it's all in there. If you do want to check out our website, feel free to do so. Of course, as with every company, we're looking for good people. So please reach out if you're interested. We're also a Google Cloud partner, which we're quite proud of because, for example, we actually do run Kubernetes in production, which is quite a thing apparently. So going serverless with Google Cloud Run. First, let's like set the baseline here, and let's take a good look at like what is serverless, what is the definition of serverless, because everybody has a different idea for it. The definition, I'm taking this one here from Google. It's a paradigm shift, they say, which enables us developers. So I'm a developer. I'm not an infrastructure kind of guy. I'm more of a developer. It allows me as a developer to focus on writing code without worrying about infrastructure. I think that's a great start. The benefits of it are zero server management. So basically, I just give it my code and then it runs it for me. There's no upfront provisioning necessary, and it also auto scales. So this is quite nice. For example, Google Cloud Run, which we will be talking about today, it scales down to 0. So if there are no requests hitting your application, then it's basically not running and you're not paying. If there are many requests hitting your application, then it will automatically upscale so that it can handle the load, which is quite nice because as a developer, I really don't want to worry about it. And then the use cases, well, it's perfect for stateless HTTP applications, IoT backends, and stuff like that. The most important word here is stateless. Let this be clear. So if you are making, for example, a PHP application, which uses sessions, that won't really work on Cloud Run because it has to be stateless. On the other hand, if you write an API that uses JWT tokens, that's like a perfect thing to run on Cloud Run. So that's the baseline, the definition of serverless. I think we're all like agreeing on this one here, and then we can continue. So let's take a look at the offerings that the Google Cloud Platform has to offer us regarding serverless. They have three things that they can offer. The first one is App Engine, the second thing is Cloud Functions, and then the third one is Cloud Run. So we'll focus later today here on Cloud Run, but first let's compare the three, because if you're unfamiliar with the products, you might like be confused about which one is best for your use case. When we're refining it, well, App Engine, first of all, App Engine is old. It's from 2008. That's 12 years ago by now, so that's really old. Cloud Functions on Google are fairly new. That's from 2017. And then Cloud Run, it launched in October or November 2019. So that's really, really recent. What do you deploy on them? Well, on App Engine, you deploy a full serverless HTTP application. On Cloud Functions, you deploy serverless functions, of course. And then on Cloud Run, you deploy serverless containers. So if you want to use the buzzwords, if you prefer to use the buzzwords, here they are: platform as a service, functions as a service, and then containers as a service. So these are the three. What languages are supported? Well, with the platform as a service from App Engine, you are limited to what they have to offer. So you can run Java, PHP, Node, Python, and Go. That's basically it. Also, you can't run all of the PHP versions. I don't know which ones they support now, but it was always the case that they were one version behind. So, for example, when PHP 7 was around, you couldn't immediately run it on the App Engine. So that was a bit of a pity. Then the Cloud Functions, they only support 3 languages, Node, Python, and Go. There is no support for PHP. What you can then do in that case, if you do want to write PHP code, for example, you can shift to Cloud Run and then run it there. Because on Cloud Run, you are not limited. So Cloud Run is the rightmost icon. You can run any language there, any library, any binary, because basically you give it a container. So you give it the Docker file, and you can control what needs to be installed inside that Docker file, which binaries you want to use, which libraries, and so forth. How do you configure it? App Engine has an app.yaml file, which you use to like configure the port it has to listen to and stuff like that. Then for the Cloud Functions, you can configure the runtime. So you have to choose the language. I want to run Node version 10, for example, and you have to define how much memory it can take. So it starts at 256, I think. Then you can go like 512, 1024, and so forth. You can also define if your Cloud Functions should be publicly accessible or not. So you can have private Cloud Functions, or you have public Cloud Functions. The public Cloud Functions, you can trigger those over HTTP. So you make a call to it, and then it executes, and it does what it needs to do. You also can have private functions, which can be run as background functions, and they can be triggered using PubSub. There's this nice integration, by the way, on Google Cloud Platform, for example. You can write an unzipper cloud function that unzips a zip whenever a file is uploaded to cloud storage. So if you upload a zip file onto cloud storage, then through PubSub, that action gets published. Like, hey, there was a new file uploaded. And then your unzipper cloud function can pick that up, unzip the file for you to another bucket, and then you're done. Or image resizing is also a great one. If a user uploads an image to a bucket, you can automatically like resize in different versions and in different formats if you want it. And then for Cloud Run, the configuration, it goes through a Docker file. So if you're familiar with Docker, that's really easy. Well, easy. You have to know a few things, but it's quite easy to understand. So these are the configuration options for the 3. I'm talking about Google Cloud Platform here today. Do note that it's not limited to like only Google. The other providers also have similar offerings. So on Google, we have App Engine, Cloud Functions, and Cloud Run. But then on Azure, we have App Service, Functions, and Container Instances. So they provide the same kind of things, although you have to like, there's different ways to configure them, and some have more options than the other. The same goes for AWS. They have Elastic Beanstalk, Lambda, which was the first, I think, regarding Cloud Functions. And then they also have ECS, Elastic Container Service. But so let's take a look at Cloud Run, because that's like the topic of this talk. Before we continue, let me just say that since I'm a developer, I like stumbled into the whole Cloud Run part from the developer side. I think that's quite cool because my colleagues here are more infrastructure people, so they like juggle with Kubernetes and things like that. I think it's nice to have like stumbled in it from the developer side, and I quite like it, Cloud Run. So how do we approach something to Cloud Run? Google Cloud Run, first, like descriptions, what do they do? Well, they run containers, say it's containers as a service. So you give it a container. It can scale down to 0. So that's also quite nice. If there are no requests hitting your app, it's not running. And it's built on Knative. This is an important one because Knative, that's like an open API to define serverless workloads. So it's not limited to Google since it's open. So you can also, like Knative can also be implemented in your own on-premise infrastructure or stuff like that. So you can also use it there. There are 2 flavors. One is a Cloud Run fully managed. That one is managed by Google. And that's the one I prefer, because the other one, Google Cloud Run for Anthos, that's out of our league, I think. If you're familiar with Anthos, then you have like a huge application. It's like for the Netflixes of this world. What it basically allows you to do, Anthos, is like run your workloads across several Kubernetes clusters across providers. So you can have an on-premise Kubernetes cluster, you can have one in the Google Cloud platform, you can have one with Azure, and they all talk to each other. That's the Anthos thing, but that's like way out of our league. And another feature of Cloud Run is the pay-per-use. So we only pay what's actually being consumed, which is quite nice. How does it work, the pay-per-use? Like here we have, for example, 2 requests coming in. The first one, request 1, is the green one, and then the second one is the red one. If they do have the same color for you, congratulations, you're colorblind. If they don't, yeah, you're not colorblind. So the first one, the green one, it starts and then it ends, and then the second one comes in, and the second one ends after the first one. So what you're actually built at Google Cloud Platform is like the whole part, from the start of request 1 to the end of request 2, and then they narrow it down to the nearest 100 milliseconds. What do you need, like, to run something on Cloud Run? First, you need to install the Google Cloud SDK. That's a G-Cloud binary. I think you can install it through Homebrew and the regular providers like apt-get and yum install and stuff like that. So you can get it. And then through the G-Cloud binary, you can communicate with the Google Cloud Console. So the Google Cloud Console, you can do everything on the web. If you surf to console.cloud.google.com, you can like click somewhere and then say, I want to deploy a new cloud function. Here is the zip with the code, and configure it and stuff like that. Or you can just use the G-Cloud binary from the shell and J and say G-Cloud function deploy, and you're off with it. So we need the Google Cloud SDK. We also need, well, of course, a Google Platform account. But what is important is that we need to link our billing details there. Because you do have to pay for things that are being handled by Cloud Run. And you, of course, have to define a project in there. And then you have to enable some services. So basically, by default, when you create a new Google Cloud Platform project, only a few services are enabled. Then you can enable services one by one. Like say, if you want to make a use of Cloud SQL, like that's an online PostgreSQL or online MySQL server, you have to enable the service first. So which services do we need here? Well, of course, we need the Cloud Run API to be available. So we need to enable that one. We also need container registry. If you're not familiar with that, we'll talk about it later too, but let's jump ahead here. Basically, when you build a container, you have to store it somewhere in a registry. And then Google Cloud Run will take a look at the registry and say, okay, I want to deploy this image right here from the registry. I want to deploy it. So we need the Cloud Run and the container registry, and then optionally we need to enable the Cloud Build API. We'll talk about that one later. So here is an example of a PHP file, of a PHP application. At the top I have a PHP file. It says hello world, and then at the bottom we have our Docker file, which says, okay, we're going to take the basic PHP 7 application. We're going to change the Apache config not to listen on port 80, but to listen on the environment variable named port. And then we are going to use our own php.init, like to configure PHP. We copy our whole application in there, and then it's ready to be run. Regarding that port environment variable, that one is set by Google Cloud Run. The default value right now is 8080. So Cloud Run won't listen on port 80. They will listen on port 8080. That's quite important to know. If you're worrying about like, oh, what about HTTPS and stuff like that, they'll do it for you. So whenever it is deployed on Cloud Run, you get a certificate with that, and it's deployed on HTTPS and then your application name, a random name, and then .run.app. That's the URL. Do note, of course, this is a very simplified example. Don't run this one in production here. Your Docker file for production should look way more different there. And then, of course, well, you also have similar images for like Node. You start with I think it's a node and then the version that will colon 12. Like for example, you want to start with that one. You copy in your files, so your dependencies, your node modules folder, and then you're off with that. So this is how we configure it. We can test it locally. So these are the local commands. If you're not familiar with Docker, these are the commands. So basically what we say using the Docker binary, say, okay, hey, we want to build our application. We're going to tag it with my app. So that's the first line there. And then the period at the end, that's important one. That one refers to like the current folder. What Docker build will then do is take a look at your Docker file and it will start interpreting that and building your image. And at the end, you have an image stored locally. Then on the second line, we are going to run our container. We're going to set the environment variable port to 8080. We're going to map our local 8080 to the 8080 inside the Docker container. And then we are going to run it using the name my container. If you want to test that out to see like if things are working, we're going to make we can make a request to our local host 8080, and then it will be forwarded into the container. Then we can check the logs if you want, and then we can also stop the container. So with this, like we have basically built our container locally, we ran it locally, and we have verified that it's working okay. It's a small step, like just to make sure before we go further. But what we want to do, of course, is like we don't want to run it on our computer. We want to run it into Google Cloud Run. So what we do then there is we also use Docker build to build the image locally, and we give it a different tag. We don't tag it like with simply my app. We tag it with eu.gcr.io, then the name of our project, and then the name of the app. The EU prefix here, that's specifically for us here in Europe, if you're following from Europe. By default, it's simply gcr.io, but the default zone that Google then uses is somewhere across the pond in America, and then your image will be stored there in that zone. The problem with it, if you store it there, like way over in America, and you then deploy it here on Cloud Run locally, like in Europe West 1, then it needs to transfer the image from there and you will pay for it. But if the transfer of the image happens inside the same zone, you don't have to pay for it. So that's why we use eu.gcr.io here, the prefix, to make sure that it is here in Europe, and then it will choose like the default one of your project. And I've set it to Europe West 1, that it's here in Belgium. So we build it locally with that tag. We push it to their registry, so the EU registry. We push it to there, and then we use the gcloud run deploy command to deploy it. So we give it the name of my service. We refer to our image that we have just pushed to the cloud registry provided by Google. We say in which project we want to run it, in which region we want to run it. The platform, we set it to manage, so not the Anthos one, but the fully managed one by Google, and then allow unauthenticated basically means like, okay, this API endpoint or our application should be invocable through HTTPS without any authorization. So that's nice. What we have here basically is we build it locally and then we run it on Cloud Run. We get a run.app URL somewhere. It's generated for us. Nice. But what we of course want to do is like we don't always want to build it locally. If we like think a bit further, we eventually want to end up with a deployment pipeline, an automatic build pipeline, so that if we push somewhere to a repository, it will automatically be built and automatically be deployed. For that, we can use Cloud Build. That's a service from Google. Later on, I'll show you like how we can link it up to like the repository and the Cloud Build. But we can also run the commands locally. So we, from our computer, can instruct Google Cloud Build to basically build our image for us. They have more CPU power. Well, they should have more CPU power, so it should go faster. The cloud build thing, so what does it do? Well, we build on Google Cloud's infrastructure, not on on our local computer, we get a free 120 build minutes per day. So that's quite nice. And then you have to pay a small amount per extra build minute. You have 10 concurrent builds, and then the native Docker support, that's a nice one. So if you push some code to Cloud Build, like you give it the contents of a folder and you say, hey, Cloud Build, build this for me. If it finds a Docker file in there, in the root, it will automatically say, okay, I'm going to use Docker to build an image. If it doesn't find a Docker file in there, well, it won't know what to do exactly with it, but you can configure that if you want. But the native Docker support, I quite like it. It's like an auto detection of a Docker file, and they automatically build it. So what's the command that we use? Well, basically we say gcloud build submit. Again, we give it the name of our tag, and then it will upload the contents of your local folder and will upload it to Cloud Build. Cloud Build will then build it, and then using the same gcloud run deploy command, it's the same one which we used before, we can deploy our build app onto Cloud Run. Of course, you have to wait for the build to finish, and then only then you can deploy it. One side note though, first, one thing you have to do, it's like a small extra step. You have to run gcloud auth configure docker on the CLI. And it will then basically do some magic, like to know which credentials to use and stuff like that. You have to run this one. It's straight from the README. You just have to run it. But once you've done that one time, that command, you can always do gcloud build submit and then gcloud run deploy. That's no problem there. Of course, when you deploy something to Cloud Run, you get a custom .run.app URL. It's one from Google, and then some characters before it. You can't really choose it. It's a bit of a shame, but you can also link your own domain. For example, if you have api.yoursite.com, you can link it. So first you have to verify your domain using gcloud domains verify. Basically what you have to do is set up a TXT record, a DNS record, to verify that it's yours, and then it will say, okay, it's yours. And then you can create a mapping for your service and map it to your own domain. Again, we pass in the platform managed, we pass in the region, and we pass in the project that we want to use. So that's quite nice. What we have here is basically, what we have here is we build it on Cloud Build, and then we deploy it on Cloud Run, but locally we have to type in the commands. If you want to clean up, if you have deployed something, you can clean up through the Google Cloud Console, the website, or you can run this command, of course. It's run services delete. What you can also do is you can deploy with a click. This is quite nice, but it only works for public repositories. So if you have your code in a repository on GitHub or on GitLab or somewhere else, all you have to do, and it's really all you have to do, it's really that all you have to do is add a link to deploy.cloud.run. And if you click that link, then you end up in ssh.cloud.google.com, and it will automatically clone the repository, build it for you, and deploy it onto Cloud Run. So this is a nice feature. If you make an open source project and you want people to test it out, you can add this link. Of course, the people that will deploy it, they have to have a Google Cloud Platform account, they have to create a project, and they have to have linked their building. So that they do have to do. But I think this is a nice feature. But of course, what we want in the end, or what I like at my job, is to have it all automated. I want to have a continuous build pipeline, continuous deployment, a build pipeline. So whenever I push something to our private repository, that Google Cloud Build automatically picks it up, or another build system, and it automatically gets deployed to Cloud Run. And that's perfectly possible. We have two options here. The first one is Cloud Build, because we have already used it. So we basically just have to link the repository with the Cloud Build thing. I'll talk about that later. And also GitHub Actions, they are also quite nice, especially their version 2 that they launched a few months ago. It's really, really powerful. I'm really impressed with GitHub Actions. Nice work there. So first, let's focus on Cloud Build. The thing you need to do is on GitHub, you have to go to GitHub, and there you have to install the Google Cloud Build application. What this thing does is it provides the link with Cloud Build and your GitHub repositories, and you can configure it to only allow a certain set of repositories to be visible by Cloud Build. And then they generate a token in the background for the communication, and it all works. So install this one. You only have to do it once. You have to, of course, then link your organization and things like that. But once that is done, you then go to Google Cloud Build on Cloud Platform itself, on the website, on the console. Then you can link your repository there. So what you see there on the right, I select the project. It's Cloud Run example. I select the project. And then in the second step, I select the repository, which is accessible through the application we just installed. And then the trigger settings. So you can say on every push if there's a new branch somewhere, if there's a pull request, you can also automatically have it built and deployed, have it built. That's the first step, and then deploying is a later step. So that's all possible. By default, it will basically, again, look for the Docker file if it's in there. If you don't have a Docker file, or if you have a Docker file that is not in the root, or if you want to run some extra commands, you have to use a cloud build.yaml file that you also put in your repository. So in the root of your repository, you put the cloud build.yaml file. You can put it in a different folder if you want, like with the repository selection in step 2. You can say, okay, it's in this folder, the cloud build.yaml file. And that one will be executed. Here's an example of a cloud build YAML file, and you should recognize the commands because they are the same commands that we executed before locally on our machines, but we just define them here in YAML. So the first one again is docker build with the ue.gcr.io on our project. The second command that we invoke is docker push, so we push it to the registry. And then the third command that we execute here is gcloud run deploy with the name of the service, the project, and then it gets deployed onto Cloud Run. So if we set up this thing right here, this is slide back. Now let's go slide forward. If we set this thing right up here, it should all go automatically, but that's not the case. If you only do these 2 steps here, you will get back an error, a permission denied error, and it says the caller does not have permission. And that's correct, because by default, the security in Google Cloud Platform is really, they thought about it. Cloud Build can't access Cloud Run by default, so you have to give it access. You can do it manually using the console by enabling the Cloud Run permission there. So it's marked in red. Or you can also invoke some extra commands, again, using the gcloud binary. So you add an IAM policy binding, and then you allow the service account to run as a default compute account, and then it will work. So if you then push to your registry, Cloud Build will pick it up, it will build it automatically, and then the third step, the deploying step, will work because we have set the permissions here. So that's Cloud Build. So this is all on Google Cloud Platform. We can, of course, also use GitHub Actions, which are very popular. The steps, again, they look very similar to what we have seen before. So if you want to build with GitHub Actions, we are not building on Google Cloud, on Google's infrastructure. We are building on GitHub's infrastructure. We have 2,000 build minutes per month. So these here are free per month, whereas with Cloud Build, you have 120 minutes per day. So depending on how big your team is or how many times you push, you can get there with the free plan with one or the other provider. Additional build minutes here are a bit more expensive. Perhaps the pricing changed, I'm not too sure. You have 20 concurrent builds, and also if you have a pro account on GitHub, you don't have 2,000 build minutes, you have 3,000 build minutes and 40 concurrent builds. That's quite nice. So how do you configure the GitHub Actions? Again, that's through a YAML file. But that's for the next slide. First, this one here. One security recommendation that I would like to give you is please use a separate service account. So on Google Cloud Platform, create a service account. and give it these 4 permissions so that it can manage Cloud Run. It can manage the storage because the image has to be stored somewhere, in a bucket. And also service account user, that one is also needed. So you have to give it these permissions. And then here in GitHub, in the settings, I have set up the secrets to use that service account. So my whole container will be built and deployed using the service account and not my personal account. We set it up here using the key. So we give the project ID as a secret, and then the service account, the email address, and the key. It's actually like a certificate. It's a CRT file, but stored inside of a JSON file. Yeah, it's a bit confusing. So how does it look, our workflow.yaml? We run it on Ubuntu. The first thing we do, again, is we check out the code. So we do a git clone. Then we set up the gcloud binary with our service account that we provided with. And then we again do the one-time thing that we had to do on our computer, the gcloud auth configure Docker. Using Docker, we then again build our image. Then we push it to the registry, and then again we do gcloud run deploy, and it will be deployed. I've added an extra one in there. It's this line right here. Set env vars. You can also inject like environment variables in there. That's also possible. Yeah, you should see my cursor move on top of it. And then as an extra, the environment variables, I automatically like to define it based upon the name of the branch. So here, if the branch is master, we set the environment to production. If it's develop, we set it to staging. You can also, of course, add extra clauses in there to just use the branch name or something like that. That's also possible. So with this workflow.yaml file, we add it to our GitHub repository. And that one will work. We don't have to configure anything on Google Cloud Platform, except for creating the project, of course, and enabling the services. But whenever we push to GitHub, the GitHub action will build it, push it to the registry, and deploy it for us. So these are the two. And this here, my friends, is the end of this presentation. I don't have anything else more to say about it, except for, of course, if you have any questions. And here are our sponsors. I see some claps here. If anyone has a question, please feel free to send it over into the chat. I know there is one question that always comes back, is like, okay, the pricing, is it really, thanks Philippe, nice talk, thanks. Regarding the pricing, like, is it really that cheap? Well, the answer is there, like with anything in web development, it depends. If you have a service that's not being requested heavily, it's not running constantly, then you're really fine with Cloud Run. If you do have like an application that's constantly being hit, constantly has to do things, then your Cloud Run bill, it can become expensive. At that moment, you do have to make choices, like, do you want to set up your own Kubernetes cluster and run it in there? That's perfectly fine, but you do have to have the knowledge at that moment of time. You also need to have the folks that are able to do it, because from that moment on, you are responsible for it yourself. So Cloud Run, I think it's really great, but at a certain time, like your bill can become too high, and then it might be good like to look out for other things. You can do also like, you can have more simple things, of course. You can split off certain parts to like cloud functions. That's also something that's possible. So the pricing, it's cheap until you hit a certain threshold. A question from Philippe here. You as a developer, do you prefer cloud functions or Cloud Run, and why? Good question. Thanks, Philippe. I prefer both. So if I write something with Node, it's like a simple standalone version function that needs to do something. Then I prefer to write it in Node, and I deploy it on Cloud Functions. For example, the unzipper that I talked about, like to automatically unzip because it's tightly integrated with the whole Google Cloud Platform ecosystem through PubSub, the trigger. Or an example that we use today is the calculation of a weather forecast. So the weather forecast part that's put inside of a cloud function. Then we use Google Cloud Scheduler. That's basically cron tab, but in the cloud. We use Cloud Scheduler to call it 3 times a day, and then we put it in a cloud function. Some other pieces of code I have written in PHP. Since Cloud Functions don't support PHP, I then fall back to Cloud Run. It all depends. Sometimes I also make a choice in favor of my colleagues. So I have my colleagues at vBridge. They are more Python developers if they do write code. So at that time we opt for Cloud Functions, and we then choose Python as a language. So basically we adapt to the use case and to who's working with the code. Mark as, oh, there's a button here. Mark as answered. Yes. All right. Are there any more questions? If you are wondering regarding the slides will be put online on my blog. The link is here. It's bram.us. It will be placed on there. So no worries. You can like copy paste all the commands. There are also some blog posts on there, for example, regarding the permissions thing. I've also written a post about that. It's right there on my blog. All right. If there are no further questions, let me leave it at this here. I'll stop the camera, I'll stop the mic, and then I want to thank you for attending. I think it's a lovely day to attend a conference. The sun is shining here in Belgium. I like the conference too, JSConf. So thanks for having me. Thanks for your attention, and perhaps we'll meet in real life at a later time. Bye-bye.